Benchmarking.
Yes. That's a big topic.
It is.
Yeah.
Okay, I have a general understanding of what benchmarking goes into, but what is it exactly in terms of how you do it, and what are you trying to determine, and what can you do it with in terms of the PC hardware?
So in broadest terms, benchmarking is just testing and comparing the performance of various pieces of hardware or an entire PC or really whatever. When you go and you buy a car or you shopping for cars and it says it does 0 to 60 in 5.8 seconds or something, some guy got on a test track and stepped on the accelerator and as fast as he could accelerate, did it over and over, and figured out how fast he could go. That's benchmarking. And doing that with PCs or PC components, sort of the same thing. You're just trying to see how fast something goes. So that's the nutshell. There's a million different things you can do to test that kind of stuff.
Now, do you use a specific setup depending on what you're actually looking at? Like, say, you're going to look at, say, maybe a CPU versus a graphics card, or how does that hardware setup work?
Yeah, it's different for different things. So let's say you're testing a hard drive, for example.
Okay.
You want to test data transfer speeds, and there's software out there to do that, or you could do things like copy files and record the time that it takes. You would want to make sure that you test all your hard drives in the same computer, so you have the same hard drive controller and the same CPU and all that stuff. So none of that stuff affects the results. It's all just the hard drive. And then, you do any of those things I just mentioned and get, let's say, a data transfer speed, 50 megabytes a second. Then you would test another hard drive, see what its data transfer speed is, 60 megabytes a second or something, and then you can compare those things against each other and just see which is faster.
What kind of tools are involved? Is it always software, or is there ever any kind of hardware basis for testing as well? I mean, in addition to, say, the PC itself.
Yeah, there's not a lot of hardware involved in benchmarking PC stuff. There are things like, you could measure the temperature of a CPU using a laser thermometer or something. You could measure the acoustics of something with a sound pressure meter. You could measure, if you wanted to measure like a power supply, you could have special hardware that generates a load on the power supply, and so it's consistent from things, and you're not relying on PC hardware to do that. But for the most part, it's all software, and that's what you really want to test, is you want to test how fast a PC runs different pieces of software. So we sort of have an example up on the screen. A very common benchmark for 3D graphics cards is 3D Mark 06. There should be a new version of 3D Mark coming pretty soon. And this runs through a battery of 3D graphics tests. You get a certain frames per second on every test. You see on the screen now some of the tests, to choose which tests to run.
Which tests can be run.
You can set different resolutions and all these things. Of course, you would want to keep that consistent from one graphics card to the next. And then it spits out a results score. We'll bring that up over here. Just slide that into view. There we go. So this particular machine got 2,164 3D marks, which isn't great. We don't have a great graphics card in this machine.
Okay.
And so how does it come up with that score? Well, every benchmark might be different on how it comes up with its score, but in this one, it got a certain number of frames per second in each test there, and then it uses a formula. It weights them. It says, multiply test 1 by 3, multiply test 2 by 7. So it adds them all up, and it puts different weight on different scores. It gives you an ultimate 3D Mark score.
I take it also goes into what specific features the particular hardware supports as well, or not, and that also factors into whatever
there's a
minimum score is.
In that particular test, there isn't. And you don't earn 3D marks by having certain features. You just need a minimum feature set just to run it. And it runs the same feature set on every graphics card.
I peek into your cube every once in a while where you do a lot of your testing, and I see actual games running sometimes in it seems like a loop-type benchmark. Is that also a common thing to use as actual software?
That's actually, in a way, more valuable. 3D Mark, because it's not a game, it can be consistent, and it can test things that games don't, or test things that future games will use, but it's not a game yet. But you also want to test real software. So we often, if we're benchmarking graphics cards or CPUs, we'll run a game. Games sometimes have performance modes built in, sometimes they don't, but you measure how many frames per second you're getting, and then you can judge that versus other pieces of hardware.
What are some of the software tool differences between, say, testing CPUs versus testing graphics cards?
There's a lot of difference because CPUs do a lot of things that graphics cards don't right now.
Okay.
So if you're testing a CPU, for example, you might be interested in knowing how fast it does video encoding. Well, that's not really something graphics cards do right now, maybe coming soon, but for right now, video encode is all done on CPUs. So you would take a video clip and you would encode it with a certain parameters to a certain format, time how long it takes to encode it. Then on another CPU, you just test the exact same video clip, the exact same settings, everything the same, so you can just time it, see which one got it done faster, and you know this CPU is faster.
Are there any crossover applications that could be used for both, maybe with different combinations of settings, that type of thing? Or
there are, but it's kind of limited right now. Video decoding is commonly done on graphics cards right now. So you can, if you were, let's say, playing back a high-def video stream from an HD DVD or Blu-ray disc or something like that, all the modern graphics cards decode all that stuff in hardware, so you can measure their performance of doing that. But you can also turn all that off and do it all on the CPU, which is extremely taxing on a CPU. Even a modern high-end CPU gets very taxed decoding HD stuff.
Sounds like one of the main keys, though, really, is just being consistent with your hardware setup and consistent with your test setup in terms of the software and how you configure it for the runs that you do to produce the data.
Yeah, I mean, that's really the key, is to make sure that whatever it is you're testing, you're not testing anything else. Everything else in your test setup is the same thing, as close to the same as you can get it, so the only differences are the one piece of hardware you're testing. And then, of course, just to make sure you use all the same parameters and settings and all that stuff so that you get, really comparable results.
How do you deal with, different graphics card drivers in terms of changing between them on the same PC setup?
That's kind of a nightmare. It's new graphics drivers drop all the time, and they always change performance in something. They're always improving performance in games. They're improving performance and quality of video decoding and stuff. So you just have to say, well, these are the drivers that we used when we ran these tests. And if there are newer drivers out there, you might get different results. And you just have to kind of keep updating those things every time you do new reviews. Make sure you have the latest drivers. Make sure you're...
Do you just run an uninstall utility for the particular driver? Say if you're switching between brands of cards or different driver builds, or what?
Well, both NVIDIA and ATI, which is pretty much everybody in the graphics business these days, or Intel's integrated graphics, their graphics drivers do have uninstall things when you go to add remove programs. They just have nice utilities that wipe out everything of the previous driver. Then you install the new one, and you're good to go. Yeah.
Thank you. Well, a good amount of information.
Yeah.
Is kind of an insight.
Just to give some people sort of an idea what it looks like, go ahead and fire off the 3D Mark real quick. And
I gotta say, usually I load these up just to see.
A lot of people have seen this, but you can get just sort of, it's, first it's going to scan what the hardware is.
The pretty pictures. Yeah. And the high-end graphics, usually, I don't know, stress old systems. Yeah. I can hear our PC underneath the table winding up as it prepares to load this intro.
Now, that we don't have time to show the whole thing, of course. It'll take some number of minutes. But, this is it's a pretty graphics scene, and there's several different ones that stress different parts of the graphics
showing
card.
A frame counter, frames per second, as well as the time code for the scene that's being run down there at the bottom.
And it's a pretty low frames per second on this particular system.
5.
We've seen systems that get 70 frames a second in this particular test. With the multiple high-end graphics cards.
Good deal.